On July 1st, 2025, a small telescope in the mountains of Chile picked up a faint dot of light moving across the sky. Nobody watching that first blurry image had any idea they were looking at only the third object ever caught passing through our solar system from another star. Astronomers gave it a strange, almost forgettable name, 3IATLAS. But what they would learn about this frozen traveler over the next year would turn out to be one of the strangest and most genuinely mind-bending science stories of our time. Not because of aliens, not because of secret signals, because the truth about this comet, the real, confirmed, peer-reviewed truth, is stranger than most fiction. Here's the number that should stop you in your tracks. This comet is older than our sun, not a little older, possibly billions of years older, while Earth, the sun, and every planet in our solar system were still just a cloud of gas and dust waiting to collapse into existence. This chunk of ice and rock was already drifting through the galaxy, formed around a star that may have died long before our own star was even born. Think about that for a second. Every sunrise you have ever seen, every single day of human history, this object was already out there, older than all of it, silently crossing the dark space between stars, waiting without any plan or purpose for a chance encounter with a solar system that did not yet exist. The object was first spotted by a survey system called ATLAS, short for Asteroid Terrestrial Impact Last Alert System, a network built specifically to scan the skies for anything that might be heading toward Earth. When it picked up 3IATLAS, the object was still incredibly far away. About 410 million miles from the Sun, sitting roughly where Jupiter's orbit is. At that distance, in that first grainy image, it was nothing more than a moving speck. But moving speck or not, its path told scientists everything they needed to know within days. The shape of its orbit was hyperbolic. In simple terms, that means it was not looping around the Sun the way every planet, moon, and ordinary comet in our solar system does. It was on a straight-line path, cutting through our solar system once, and only once, before leaving forever. Objects born here do not move like that. Only visitors from outside can. This made 3IATLAS just the third confirmed interstellar object in recorded history. The first, called Oumuamua, was spotted in 2017, a strange elongated rock that tumbled through so fast and so faint that scientists barely had time to study it before it vanished from view forever. The second, 2I Borisov, came through in 2019, behaving more like a normal comet but still too dim for detailed study. 2 visitors, 2 enormous missed opportunities, 2 sets of unanswered questions. Then came 3IATLAS, and this time, everything was different. This comet was big, not small and shy like the first 2, but massive by comparison, with scientists estimating its icy core somewhere between 440 meters and 5.5 kilometers across. Being larger and brighter than anything like it before meant one thing. For the first time ever, humanity had a real, sustained chance to study an object from another solar system up close, with our best instruments, for months at a time. And we did not waste it. Word spread through the astronomy community almost instantly. Telescopes across the planet and even beyond it turned to track this fast-moving visitor. When it was first found, 3IATLAS was already screaming through space at about 137,000 miles an hour. As the sun's gravity pulled at it, that speed only grew, reaching around 153,000 miles an hour at its closest approach to the sun in late October 2025. To put that in perspective, that is roughly 200 times faster than a commercial airplane. It was never going to stick around, and everyone studying it knew that. Every observation, every scrap of data had to be grabbed while there was still time, because once this comet swung past the sun and slingshotted back out into deep space, it would be gone. Forever. No second chances, no follow-up missions, no do-overs. Whatever we learned in this narrow window was all we were ever going to get. That urgency is what pulled in one of the most powerful tools ever built by human beings, the James Webb Space Telescope. Webb was never actually designed to track something moving this fast. It is built for staring at distant, essentially motionless galaxies and exoplanets, not chasing a rock hurtling through our own solar system at incredible speed. But the team behind Webb had been waiting for a moment exactly like this. One scientist involved, who had been fascinated by interstellar objects since the days of Oumuamua back in 2017, pushed to get Webb pointed at the new visitor as soon as it was found. By August of 2025, against the odds, Webb had successfully captured a full spectrum of light from 3IATLAS, essentially a chemical fingerprint of what this ancient traveler is actually made of. What Webb found did not disappoint. Buried in that spectrum was something remarkable, a huge, unexpected abundance of what scientists call heavy water. Ordinary water is made of 2 hydrogen atoms and 1 oxygen atom. Heavy water looks almost identical, but with a twist. One of those hydrogen atoms is replaced by a heavier version called deuterium. The ratio of ordinary water to heavy water in any icy object is like a fingerprint left behind at the exact moment and place that object first formed. It does not really change much over time. Once it is locked into the ice, it stays that way for billions of years. And the ratio locked inside 3IATLAS is unlike almost anything scientists have measured before. In any comet, anywhere, ever. It is telling us something specific about the freezing cold outer edges of some other ancient star system, one that existed long before our own sun ignited. To dig even deeper into that mystery, another team turned to ALMA, the Atacama Large Millimeter Array, a collection of enormous radio dishes spread across the high desert of Chile. ALMA's instruments are sensitive enough to separate ordinary water molecules from heavy water molecules with incredible precision, something that had never been successfully done on an interstellar object before this comet came along. Their results confirmed and sharpened what Webb had already hinted at. This water is strange. It does not match the water we find in our own solar system's comets. It points to a formation environment that was colder, older, and fundamentally different from the one that built our own planets. Then, in a separate and equally striking discovery, researchers using the European Southern Observatory's Very Large Telescope in Chile went looking for even more chemical clues. Around January of 2026, they managed to capture detailed images and spectra of 3IATLAS as it continued its journey. What they found, published not long after, was that the comet's chemical fingerprint matches the kind of environment you would expect from the far outer edges of an old, established star system, one built around a star considerably older than our own sun. In other words, this is not just a piece of ice from some random young star nearby. This is very likely a fragment of a much older cosmic neighborhood, a place that may have existed and finished forming while our own sun was still just a swirling cloud of gas. Read that again because it deserves to sink in. This object could be the oldest comet human eyes have ever studied. Not the oldest comet in our solar system. The oldest comet, period, that any human being has ever laid instruments on. Every rock, moon, and world we know intimately. Our moon, Mars, the ice of Europa, formed around our 4.5 billion-year-old sun. This thing may be older than all of it. It may have been drifting silently through interstellar space since before Earth's story even began. As the months rolled on, more instruments joined the chase. In December 2025, NASA's SphereX mission, a spacecraft designed to map the entire sky in infrared light, caught its own detailed readings of the comet's glowing coma, the cloud of gas and dust that forms around an icy object as sunlight warms it. Those observations picked up the telltale signatures of dust, water, organic molecules, and carbon dioxide streaming off the comet's surface as it reacted to the heat of the sun. This is completely normal comet behavior, the same basic physics that plays out with comets born in our own solar system. Ice forms, gas escapes, a tail forms. But knowing that 3IATLAS behaves in a recognizable way makes the differences in its chemistry even more meaningful. It is acting like a comet, we understand, while being built from ingredients we have never quite seen combined this way before. Then, in the spring of 2026, came a finding that genuinely surprised even seasoned comet scientists. A team studying fresh Webb data announced the first direct detection of methane gas coming off 3IATLAS. Methane on a visiting interstellar object is a big deal. It tells scientists something specific about the temperature and the raw materials present in the disk of gas and dust that this comet originally formed inside of, billions of years ago, around a star we will likely never identify. This was not some vague hint or educated guess. It was a clean, direct detection, hard evidence sitting right there in the light Webb had gathered. Piece by piece, this ancient wanderer was giving up secrets about a solar system that no longer exists, around a star that may have burned out long ago. While all of this chemistry was being decoded from afar, something else remarkable was happening much closer to home. As 3IATLAS swept through the inner solar system on its one-way trip, its path carried it near Mars in early October of 2025. That gave space agencies an opportunity nobody wanted to miss. Multiple spacecraft already stationed at Mars, orbiters built for entirely different missions, briefly turned their cameras toward the passing comet. European orbiters caught images of it. NASA missions worked together to track it as it swept past. Then, in the summer of 2026, China's Tianwen-1 mission at Mars managed to capture the closest images of the comet taken by any spacecraft up to that point. That was no small feat. The comet was still small and dim, only around 3.5 miles across at most, and it was moving at roughly 58 kilometers per second, while its position relative to the watching spacecraft shifted at an even more staggering 86 kilometers per second. The camera doing the work, called HIRIC, was never built for this. It was designed to photograph sharp, sunlit details on the surface of Mars, not to hunt down a faint, fast-moving speck of ice and rock racing past in the darkness. And yet it succeeded, delivering some of the most detailed pictures humanity has ever captured of a visitor from beyond our solar system. Back on Earth and in orbit around it, other instruments kept a careful watch too. In January of 2026, NASA's Transiting Exoplanet Survey Satellite, better known as TESS, a spacecraft normally busy hunting for planets around distant stars, was pulled off its regular schedule for a special observation window. For about a week, TESS pointed along the path the comet was traveling, using its extremely precise continuous brightness measurements to study how 3IATLAS behaved in the days following its closest pass by the Sun. This kind of steady, uninterrupted watching is exactly what scientists need to catch subtle changes in brightness that reveal how a comet's surface reacts as it heats up and cools back down. It was a rare use of a billion-dollar planet hunting machine, repurposed for a few precious days, just to squeeze a little more understanding out of an object that would never pass this way again. So where is 3IATLAS now, and where's it going? After swinging around the Sun in late October 2025 at a safe distance, always far outside Earth's own orbit, meaning there was never, at any point, any danger to our planet, the comet continued its ancient one-way journey outward. It passed by Mars's orbit in early October. It swept behind the Sun from our point of view around the end of that month. Then it continued on, crossing back out past Jupiter's orbit by around March of 2026, picking up speed again as it left the inner solar system behind. As of the middle of 2026, it is still moving, still glowing faintly, still being tracked by patient telescopes on Earth and spacecraft scattered across the solar system, all watching a door slowly closing. Because, make no mistake, this door is closing. 3IATLAS entered our solar system at roughly the same blistering speed it will leave at. It gained speed briefly from the Sun's gravity, then gave that speed right back as it climbs back out into the dark. Once it crosses back out past the orbit of the outer planets and fades from view, it will keep traveling forever, out into interstellar space, never to return to our part of the galaxy again. Whatever data we have gathered on it before the final farewell is genuinely all we will ever get. There is no calling it back. That knowledge is exactly what drove such an intense, coordinated effort across the entire global science community in such a short window of time. Ground telescopes in Chile, space telescopes built to stare at galaxies billions of light years away, repurposed to chase a fast-moving rock. Mars orbiters built for entirely different jobs, turning their lenses skyward at just the right moment. A planet-hunting satellite paused mid-mission to lock onto a single icy traveler for a few crucial days. Scientists from NASA, the European Space Agency, the European Southern Observatory, and space agencies around the world, all racing against a closing window that would never open again. And what did all of that effort actually confirm? Something that, stripped of any exaggeration, is still genuinely astonishing. We now have strong, real evidence that Comet 3I Atlas may be older than our own Sun, a frozen fragment of a star system that may no longer exist, carrying inside it water and gases with chemical signatures, unlike anything we have measured before in our own cosmic backyard. It survived an unimaginable journey across the emptiness between stars, drifting for who knows how many millions or billions of years, only to pass briefly through our neighborhood, get examined by the most powerful instruments humanity has ever built, and then continue on its way, indifferent to us, heading back out into the dark forever. There is something almost humbling in that. This is not a story that needed alien signals or secret messages hidden inside strange readings to be worth telling. The real story is that a piece of another solar system, one that may have finished forming and dying long before our own Sun was even born, drifted close enough for us to actually study it, just this once, in the entire span of human history. 2 earlier interstellar visitors came and went too fast, too faint, too far away for us to learn much of anything. This time, for the first time ever, we caught a good look. We measured its water. We found its gases. We tracked its speed, its path, its faint glow, using tools spread across Earth, Mars, and deep space, all working together in a race against time that none of them could afford to lose. By the time 3IATLAS finally fades past the edge of what our telescopes can detect, it will leave behind more real, confirmed, published scientific data than either of the interstellar visitors that came before it combined. Papers are still being written. Data is still being analyzed. And somewhere out there, this ancient traveler, born around a star we will probably never identify in a system that may no longer even exist, continues on its long, silent journey outward, carrying its secrets with it, most of which we were lucky enough, just this once, to actually catch a glimpse of before it disappeared into the dark for good. The next interstellar visitor, whenever it comes, and astronomers expect there will be others, now has a genuine benchmark to be measured against. We know a little more than we did before about what wanders between the stars, about how old some of these travelers might be, and about how much we can learn if we manage to catch one at just the right moment with just the right instruments, pointed in just the right direction, before it slips away again. That is the real story of 3IATLAS. Not a message from another world, not a heartbeat hidden in its core, just an extraordinary, genuinely ancient piece of another solar system, passing close enough, just once, for us to finally get a good, long look.